In this section, we will introduce the application of conductive nanosheets to electromyogram, EMG measurement. Muscle potential is the action potential generated when muscles contract. EMG is measurement of muscle potentials by electrodes attached to the skin. EMGs are used in biomechanics, rehabilitation, and as an input interface for artificial limbs. EMG can also be applied to sports science to analyze athletes' movements in detail. However, existing gel electrodes have problems of stability against movements and sweat. By using conductive nanosheet electrodes, it is possible to measure muscle potential without interfering with the athlete's movement. Here we explain the actual experimental system. 2 nanosheet electrodes were attached to the palm, the adductor muscle of the mother finger. The wires were extended from the nanosheets to the wrist and connected to the device. The obtained signals were transformed by the Bluetooth device and sent to a smartphone. The nanosheet electrodes are mounted on a tattoo sticker device for easy attachment. For the wiring to the device, stretchable wiring with a kirigami structure was used so that the device could be used even during strenuous movements. Here is the actual application. By wetting the tattoo sticker-like substrate with water, the nanosheet electrode is transferred to the skin. The nanosheet electrode is equipped with a conductive adhesive film as a connector, which can be connected to the stretchable wiring. It can also be connected directly to an electromyograph. The EMG measurement while holding a ball in hand is shown here. The electromyogram is shown on the smartphone on the right. You can see that signals are synchronized in accordance with the movement of body. In this experiment, we evaluated the activity of the adductor muscle of the mother finger during pitching in a baseball game. Nanosheet electrodes and stretchable wires were attached to the pitcher's arm and connected to the device. While measuring the muscle potential, we filmed the scene with a slow-motion camera. Here are the results. In the pitching motion, which lasted only 2 seconds, we found that there was a peak in EMG potential before release. Next, we compared the results between experienced and inexperienced baseball pitchers. The experienced person showed relatively stable EMGs, while the inexperienced person showed unstable EMGs that were maximized just before release. In addition, we examined the difference of the type of pitch. It was confirmed that there was a peak EMG potential before release, but the position of the peak was significantly different between straight and curved pitches. These analyses are expected to be useful in fighting talents and improving yips. The measurement of muscle potential using nanosheet electrodes can be used for applications other than baseball, and we are considering applying it to table tennis, track and field, and esports, for example.